All right, so we are going to finish up our 5S Meter in the Swamp series here. We had three, this is the third one in a series where we were testing that 5S in the swamp there. So we did our inspections. We went through everything, looked at the pole, noted some things. The poles had recently been under a pretty good amount of water at the base of them, so they had, slid a little bit. So we looked at that. We just went through our previous stuff, like we always do. And then once we did that, we actually tested the meter. So we just finished getting a meter test. So what we're going to do today is we're going to look at the CTs and get to see some slick stick work with Jonathan, getting up there to try and get the correct phases in that high volt probe. So this is number 18. Like I said, today is going to be part 3 of the swamp. Then June 29th to be determined. Hey, did we ever get any votes? Did anybody ever send in anything, JP, about which ones they wanted to see? Or did you just pick it?
I just picked one.
Come on, you goobers.
I like the swamp.
Oh, I know you like the swamp. I'm talking about these guys.
Yeah,
Come on. Come on, man. Y'all send something into us. Tell us what you want to see. You got a choice of 3s, 4s, 5s, 6s, 9s. We got pad mounts. We haven't even, I don't know if we've shown pad mounts much anymore. Yeah, send in a pad mount that you want to see, and we'll do that one. How about that?
Yeah.
All right, cool. So today, quick recap. CT test setup, high volt probe placement, dodging alligators, and testing the CT. Nice.
Oh, and bullets.
I am bullets. Nice. So let's go ahead and start out with I like to start out with a prayer, and we'll pray us out, and then we'll get rolling. Precious Heavenly Father, thank you so much for this time today. Thank you so much for just, we forget sometimes not every country can do this. Not every country can you freely worship. Can you talk about Jesus out in public? Can you talk about the Bible out in public? You can't. So thank you so much for this country that was founded on Christian principles. And Father, be with us. It seems like every time you turn on the TV, you see something that's a little bit disturbing and goes against not just your creations, but the Creator. And so I would hope that we would turn more to you and realize that the answer is not up on a hill in our country, but it's the answer was up on the cross, and He's sitting there right beside you right now. So thank you so much for this time today. Thank you so much for this technology, and most importantly, thank you for your Son. Without Him dying on that cross, you would not see me as I am, which is just someone who has given his life to Jesus, but you'd see me who I am, and you wouldn't put up with that very much because you don't like sin. So I couldn't even pray right now if it weren't for what my brother Jesus Christ did on that cross. So thank you so much for that. And Jesus, I ask and say all these things in your name. So amen. Cool. All right, let's roll. Okay, so we were talking about the recap a minute ago. What we did was we started in, did the pole inspection, noted some foundational stuff. It had all been underwater for a while there where we were. So we did our inspections. Some of the bands had popped off when they were straightening these poles back up. The poles have been laying over, pretty badly, 45 and worse, the whole row. We'd done a pre-inspect out there, wondering if it was going to be ready for us to test on. So it was pretty rough, under a lot of water. So when we came along there, and this is a big water pump, is what it's a 480. Excuse me. It's a high sea leg site, and they're using the 480 for there's a big pump in the background you can't see, trying to pump all that water out, and that's what that's for, because this is a low-lying area, a lot of alligators, as my boy likes to say. So we got to that point. We did a meter test. We looked at connect view versus the meter view. Remember, on the meter view that it shows internally what the meter might do, where it's referencing a different voltage with the other voltages, so that you only have 2 voltages there instead of 3, or you only have 2 currents instead of 3 currents, and all that summation and things going on inside the meter. But you also can use connect view on the equipment and actually look and see where your connections were. And in the case we showed, you're actually connecting. You have 3 voltages, 2 currents. So I do have a voltage connection. I just don't have either one of my current connections there. So because I don't have that, there's nothing there you can see on the test switch. So I do have a connect view. If you look at connect view on the equipment, it shows B phase being connected If you go to meter view, it shows VAB, and it only shows, you don't see any yellow. All you're seeing is blue and red. So it's just going to show you the blue and red vectors, but it's showing you VAB. So it's like I said, if you see more than one letter off of that, it's referencing, right? So, so in this case, you can look at Connect View, though, to make sure and see where you actually make your connections there at the test switch. So we did that, tested the meter, and the meter tested out fine. A little bit in the, I believe it was a little bit in the utility's favor, just a tiny, tiny bit. So now we're getting to the point where we're ready to test the CTs, and now you get to see some good stick work of Jonathan's. So we'll roll it, and I'll just stop and make some comments as we go on. So let it go.
Now, the reason we kind of have to back up and change what we're going to do, we can't just run through with an integrated site test, is on this particular setup, you can see on our line diagram, it's showing to use 3 flex rings because it wants you to use all 3 of them at the same time. For the C phase, it's wanting to get you a wrap right there. You can single wrap right here where you've got your double loop, or you can double wrap back here just on the main line. And then it wants you to have an individual for A and B. So we actually don't have to figure 8 on this one to get it, just because of the way it wants you to do it. Mm-hmm. As you can see, we have got the high volt probe hooked up here on a probe adapter cable. Mm-hmm. But down here on the bottom, it's still saying missing probe, please check and rescan. It's going to give you that until you hook 3 probes up to it.
That's right.
Well, that's all fine and good if you're on a pad mount, or maybe you've got a bucket truck nearby, which we don't. So we kind of have to back up and trick it, I guess is the best word.
Sure.
To let us be able to do it off the ground.
So you can see to what Jonathan was saying right here, and we've talked about this before, but we haven't seen that many examples of it, but you're going to see them more as we go through this web series of, you know, you have it shows you this color diagram twice. It shows you once before you perform the meter test, and then once before you perform the CT test. So it's showing right here, it already showed it for the meter test, but when you get ready to do the CT test, it's going to show you how to make the connections up here with your CT probes up here, all right, with our primary probes in that. So you can see it gave him an option of I can single wrap right here on C phase. Remember, that's my high C leg where I've got it looped, right? So I can get single wrap here where I can get both of them, or I can double wrap over here. So it literally shows you how to make your connections. It'll even show you figure 8s. Okay, but to what Jonathan is saying here, and we're going to talk about it a little bit more as he moves forward, because the machine is looking for 3, it wants to do 3 of these primary currents, right? So it wants to put 3 flexible CTs on there. It wants to put our flexes on there. Excuse me. So that's the way it's laying it out. But we don't have that. We're out there with a high volt probe, right? So because we're out there with a high volt probe, if we try and run this test, the machine's not going to like it at all, right? It's going to keep saying missing probes because it's looking for 3 of them to be connected. If you look down here over in the lower part of the screen, we've talked about this before also. Solid green, because right now he's got a high volt probe connected to just A phase, which is what you're supposed to do. You don't move it to B and the C phase when you test B and C phase, the connections. You leave it connected just to the cable on A phase, and you move the probe up over to B and then to C. So you would leave it just connected here, primary current A. That's fine, and that's great, except it's giving you red and a red here for my primary B and my primary C because it's looking for my other 2 flexes, and they're not connected to the cable, so the machine's saying, whoa, time out, you're missing some probes here, so it's not going to let you continue with it. So that's why we've got to do something to change that, okay? Thanks, JP.
On with the stick.
We're always having to do field modifications. That's the dealing with working in the field. So, and the equipment, and when you get something like this, it's a very unusual setup like this, then we have to make it so that we have to get some sort of a configuration that'll match the tools that we've got. And today we're using a high volt probe out here. So we're going to have to match it up so we can use this high volt probe, because that diagram right there is made for if we're using flexes. Okay, cool.
All right, so I've gone in and I've edited our site and I've changed our service type. Remember before we were on 4-wire delta, 2 voltage, 2 currents, 3 primary currents. And we had to change it to be able to use our high volt probe on our stick. Now what I've gone in and I've selected is just a 3-wire delta because it's got 2 voltages and more importantly 2 currents. And you can see on our line diagram we just need 1 probe for A and 1 probe for B or C. And we can, you know, like the fork, you can do one at a time.
That's
whereas
right.
Before it wanted us to use all 3 probes all at the same time.
And if you didn't, it would continuously tell you probe missing.
Yeah. And
So
yeah, you can actually see down here on the bottom, required probes detected, press next to continue. So
Yeah.
we're ready to get the fork out.
Right. So, and as always, we've said this before. So in this case, it'll show a solid green for where he's connected onto there, and it's giving you the open green circle, letting you know you're just going to have to move that high volt probe. It's the same as if you're using one flex and you're doing 3 phases. It'll give you 1 solid green and then 2 open circle greens, because you're going to have to move that flex to the other ones. In this case, we're going to have to move that high volt probe. So it's letting it know, yeah, you're connected up, and per this, and this is what he did to match it up. It's not telling me probe's missing. It's saying, yeah, you're good to go now, and we know that you've got the 1 probe connected on one of the lines, and you're just going to have to move the actual probe around, okay? So that's what those open circles are telling you. You're going to have to move the probe. Come on, darling. You think it's gonna mess us up that that's looped like that?
I'm trying to watch your mother.
Oh, you're gonna get it on through there. Come on, baby. Turn it to the right and slide her forward.
Well, the secondary wires is catching me a little bit.
Oh, I got you. I see. Yeah, it is. Can you drop it down? Yeah, there you go. So you see where these wires right here are catching him on the back side of that? As he moves this, you're going to see that those wires, those wires right there are grabbing on it. Maybe you hung up on your knuckle a little bit.
Yeah.
I can get another stick and move him out of the way if you want me to.
Well,
You got another stick? That's so funny. That's exactly what I was thinking. Use the back side of it to get him out of the way. Do you want to get it through that loop? Is that what you're trying to do?
I was trying, because it's not really down below the fork.
Right.
I mean, we could hit it real quick and see
I'll
what
hit
it
it and
does.
see if it'll work.
It may be enough in there.
Fail.
Come up funny.
Yeah. 14%.
Now try it.
All right. Bam. Okay. Let's go back here and retest. Okay, cool. Okay, so as always, when you're using a 1 probe like this, it's always going to tell you to move the probe to phase A and then press F6 to start the test. But let's back up real quick and look up at the top of the pole real quick so we can see what Jonathan's got working here. If you've seen any of the other previous webinars, you may have heard the time that Brylan mentioned he wished he had a little adapter so he could come in flat and grab both of the conductors coming right at the base of that CT. It goes back to what John... So, what he's done is, and I'm going to give you that number here in a second, and JP's actually going to put it on a little deal, the Hastings number for this little adapter that will allow you to lay that thing flat, okay? Because you can see how well that works right here. because the closer, if you can lay it flat like that to that CT, you're catching it before they spread out, right? When you're having to grab more than one conductor like that. Because you can see right here, he's grabbed one here. You can see it goes right behind the stick right there. He's grabbed one there. But look where they are. They're already out getting pretty close to the edges of my horseshoe right there, right? The inside of it. So, but him being able to slide it in there, if he had to come farther out here, he wouldn't have a chance, right? So that knuckle right there, and I've got the number, and my boy's going to put it out there so that everybody can see it. We'll add that in there post-production. So we're going to give you that Hastings knuckle number. I would definitely recommend getting one if you don't already have it. And I were saying before about when you've got two of them coming out, remember we said if you can grab right there very close to that CT, you would just use one single loop with your flex. Well, this is that same principle, right? If we can get right there at the CT, real close to it, we can grab both of those conductors with that high volt probe right there. So with the adapter he's got and laying it flat over like that, he can get in there real close to it and slide it in. So that's what he's done. You can see where he slid it in really close right there to him, and he's grabbed both of those conductors where they're crisscrossed on that left CT there. So he's got A and B there. So we're summing them up. So we're going to come over here and hit the where it tells us over here, move the probe to phase A and press F6 to start the test. Remember, we've got A and B in here, so we're going to hit the start test right here. Perfect. So we get our pass, and it is showing that that's a 200 to 5 up there, which is correct from what we've seen. Our phase angle error isn't giving us any problems, and the ratio is good. If it had been a red fail, we would have followed the red numbers to see where our problem was, whether it was a phase angle error problem or a ratio problem. In this case, both of them meet our requirements, so we get the green pass versus the red fail, so we love that. So now he's going to get off of that, and he's going to move over here to C phase, and we're going to press the button and test C phase once he gets that high volt probe in position, all right? Ooh, I like it.
It ain't gonna go.
But it's tight, isn't it? That wire's too tight. That white wire's too tight. You know, not to be a backseat driver or anything.
I'm just gonna go straight and poke it up in there.
I was gonna say, if you go straight, you can come in like this, right? Maybe between. If you go straight where I was, see where the white wire comes down, the other one crosses down here below it.
Yeah.
Go between there and go in right like this, and so you got more room down there below them. And you can go right in, and that top fork could go right in between in your loop.
You make sure it's on. I cycled it to make sure it didn't drop dead while we were looking at it.
No, your base is good.
Okay. I turned the head off and then turned it back on.
Gotcha. Okay. Now, why would he do that? He would do that maybe to extend the time on that high volt probe. Remember, we've talked about that, right? There's a timeout on them. So if you have one of the high volt probes that does timeout, and somebody asked me about this not long ago, so I want to talk about it again. If you hit the head unit up top, we call that head unit. So we got base unit down here at the bottom. That's that one that stays down there at the bottom. Some of them have screen, some don't. And then the head unit's up there, horseshoe shaped. Well, if you get up there with that one, what you can do is when you hit the button, if it has a 0 with a decimal point on it, if you'll hit it again, if you'll hit the decimal point, hit the button again rather, and the decimal point goes away, that gives you your longer duration before it cuts off, because it's going to cut off to save those batteries. Remember, you got a 9-volt battery in the head unit, 9-volt battery in the base unit. So what it does is it'll extend out that time before it'll shut off. So that's why he did that, because it was starting to, we're starting to get a little bit longer into getting this test run. So he turned on, he just redid that head unit on there so to extend that time out. Thanks.
A little bit of wind sliding in the mud.
Heck yeah. Nice, yeah. Take your bottom and kind of gently go on that white, kind of rest it on that white one, and then slide it in the top. Yeah. That's it. Turn it to the right. Turn it to the right. Ooh, I like it. I like it. I like it. All right. So now tells us to move the probe to face C and press F6. Well, let's back up just a second real quick and look up at the top of the pole. I like to make JP run around with that camera anyway. So you can see what he's done. This is just great stick work. He's got to get through that loop, right? Because remember, we're looped through on that 480. We talked about it on how the pole, when we inspected the pole. So he's got to get through that loop. So he's got the one fork through there. So he's got his loop, so he made it through the loop with the one. But you always got to be cognizant of all those secondary wires and instrumentation wires and all those control wires up there, right? So he's had to get in between all those, but he didn't get any of the others in there. It's similar to a flex up in a pad mount. You don't want to grab extra stuff. So he's done a great job of just getting that loop in there, and he's left all those other wires out of there. So let's go hit the button and see what happens. So let's talk about that looping for a second, because you've heard me mention it a couple times. What we're doing with that is, people will call it cutting the ratio or cutting the CT, or you hear different expressions for it. And what we're saying there is, remember, this is the high C leg, right? So this is my 480 volt over there. But what you can do is to cut the ratio on that. If I have my CT, and if I run through here and I run an extra loop through there, well, what happens if I run it through twice? If I run it through twice on it, if you think about it, if this is a 600 to 5, that's a 600 to 5 CT, right? If I double loop through it, I can't run 600 through there anymore, can I? Because I'm pumping twice as much through there. It's twice whatever that number is. So now I've just derated it to, really now it's a 300 to 5. Because if I tried to run 600 through there, if I ran 600 amps through that conductor, it's really 1200 going through that CT, right? It's not good. So what you've done is, they call it cutting, or ratio cutting, or cutting the ratio, or just cutting the CT, is if you put more loops in it, if you know your loads are going to be down at the lower end, right, then you would want to pump more through there. Remember, we don't like to underload CTs. So on that high C leg over there is that big, we've got that big pump running over, that 480 volt pump that's over there running. So a lot of times, not having much load on it, they still wanted to be able to read it. So they knew the amounts would be lower, so they just went in and cut that ratio on that CT. Okay? Thanks, JP. So I'm hit F6. Come on, darling. And one time. Wah, wah, wah.
Load dropped off.
Yep, and of course the load drops off right when, and this is another thing we're dealing with. We got wind, we've got the mud, we've got gunfire, we're dealing with a pump. So we're waiting on the pump to come back on. So unfortunately right now our load's dropped off. So we're gonna hit, I'm gonna hit retest, and we're gonna wait for the load to come back up.
You forgot to mention alligators.
Oh yeah, alligators, that's exactly right. Which we found out today JP's not a big fan of, by the way.
They're dinosaurs.
You've been playing with Eldon too much with dinosaurs. That's what that's about. So, now Eldon would like them. Your son would like the dinosaurs if he saw an alligator.
Eldon is bite-sized for an alligator.
Yeah, but he would probably try and ride it. So, so let's see. Did you hear anything kick on? No.
You can look at your display and see.
Yeah, I'm not seeing nothing's kicked on. Yeah. I'm not seeing anything on that right now. Let's look. Unfortunately. So yeah, when you see. So we talk about this all the time. We talk about, you know, you've heard me say it a bunch, that high C leg, if you don't have any load on it, if the elevator's not running, or whatever it is that you've got on that high C leg, if it's not running, then you got a problem testing it, right? There's no load. Here we get into a situation with no load on the CTs, and we know what happens on that. It's not going to test them. It's going to start giving you these error messages. But what's interesting about this is, if you look at it, you would initially look at this and go, well, wait a minute, I thought you said there wasn't any load on there. But what the thing is this, you got, it looks at this, and it's almost like an auto ranging, if you want to, or an auto. What happens is it looks at the lowest one here, which was 0.007, right? And then it's got 0.001. So it's got only 0.001 of secondary current here on A phase. Well, then it's going to scale off that, and then that's the 0.007. So no, it still doesn't have any load. You need to look at the numbers over here. You can't be fooled by the vectors sometimes, because they're going to auto scale against one another, okay? So so in this case, we just don't have any load, which is what we were saying, the pump shut down. Thanks. A power factor of a negative 4.56 right there. That's telling me I don't have anything on my C that I'm trying to find. And you can see right here, absolutely zip. That's so, yeah, I don't have anything going right now, unfortunately. Let's go previous, go back to it. But that's just using the screens to tell us. Plus, we heard the pumps drop off, so we're waiting for them to come back on, but they will. Because you can see where we've been walking, they've had to move some water around in here to try and clean this area up here. So everybody's yelled. We've kicked back on again because they can see the status wheel from there. So we got it. So let's give this a shot again. So we're going to retest. We're going to retest it again. So let's sit right here and retest. Okay. Move probe to phase C. Remember what we've talked about before on the retest. It ended up right with a gold box around there at the bottom. If you've been testing all three phases, the same thing. It ends up on C phase. If you go A, B, then C, it ends up with the gold box around C at the end, and you can just move that. So you can move the gold box if you need to move it up and retest just that phase. And then it was already on C phase, so we just hit retest. You could retest all of them or retest just the one with the gold box. So we just retested C phase because we'd already tested A. All right, one time. Nice work. So we get a pass on that. It's showing 199 to 2, so it's showing us a 200 to 5 on that. But remember, we're looped, right? So we've looped it and cut it, so all that makes sense. So we've got fans going by. Sorry, we can't help it. It's a Powermetrix thing. So anyway, so everything looks good there. So our angle and our ratio looks good. So we got the green pass. So we tested the funky site and with Jonathan on the stick and everything came out just really great. So this is one of those where we're going to do a lot more work when we show this thing back in Knoxville. We're going to do some pointing to the top of the pole, maybe point things out. But I think if you really watch what we've just done so far, you can figure out what was going on. But on the 480, we had looped it. We had them crossed on the 240 side on it. So we just had to, he had to angle that fork so that he could get both of those conductors on the, where they're looped through, where they're crisscrossed on there. And then he just had to make sure he got through where it was looped over on the 480 side. So this is what we deal with, right, with my new phone. So this is what we deal with on these deltas and these 5S sites, these deltas and stuff, right? So in this case, we were looped through opposite directions. We had only 2 CTs. We had 3 voltages, 2 currents, so we only had 2 CTs up there. So we had the 2 conductors from A and B phases running opposite directions through there. So we have a choice in that situation of figurating a flex or getting close enough where you can get a flex around both of those conductors going in the opposite directions, and then it will sum them just like the meter's summing them on the inside. Or with the high volt probe, you have to make sure you get them both up in there, right? You can figurate a flex, but you can't figurate a high volt probe, so you're going to have to grab both of them and get them both on there. That's why that adapter they've got is so great, because you can slide right over the top of the CT and you can grab them where they're the closest together, which is right at the CT, right? As soon as they start getting away from that CT, they're going to spread apart the 2 conductors there. So the closer you can get to it, the better chance you have of getting around both of them at the same time. Then we remembered we had it looped over there and we had cut the ratio over on that 480 side over there, so they had looped it through twice, right? So everything, once you looked at it all, everything made sense. You just had to kind of take your time and look at it. So this is what you're dealing with these deltas. There's some great stick work on Jonathan's part. You just got to make sure you make your connections correct. Use that connect view and see, whether you should be on B phase or not. So it showed us that we should have been on B phase for the voltage, and we were, and everything worked out okay. And then there's also the meter view, which shows you which is what it defaults to, and you're going to see what the meter's seeing. Same thing the meter's seeing after it does its work internally. So in that case, it had a VAB because it was relating A to B. Okay, so it had A and B paired up together. So you can see that it'll have a VAB on there. If you see more than one letter on there for phases, then you know that it's using another phase as a reference. Otherwise, it would be very clean and be VA, VB, VC, IA, IB, IC. Okay, so so that's just we're starting to get into some of the more interesting ones now. We will, if you guys will send us in some stuff on what you'd like to see. Let's do a pad mount next, and you guys send in which one of the pad mounts that you want to see, because we've got a pad mount on all of them. So if you guys send it in and vote on it, that's the one we'll show when I get back from Oklahoma. Okay, but I'll miss you guys the next couple of weeks. I won't be here live. I'll be here in spirit. So we'll JP will run these things for you, and you'll get to see them. Any questions or comments or anything, please send them in to Jarrett, and he'll get them to me. But as always, please, everybody traveling to North Carolina Meter School, please be very careful there and back, and be praying for y'all. A lot of folks headed that way, so a lot of folks on the road, so let's be careful out there, and be careful out there in the field, all right? God bless.